Okay, when you have a matrix, we have two vector space from this matrix. That's the row space and column space. Okay. Later on, I'll bring back column space and talk about it in relation to this other vector space that we talked about. Okay. Given a matrix, we can look at it as also as the coefficient matrix of a linear system of equations. So basically, like this would refer to if you think of it as the linear system. So it's like 1x1 plus 2x2 plus 4x3 equals 0. So the first row becomes this equation. The second row becomes x2 1x2 plus 3x3 equals 0. Okay. So now you have a system with 3 variables and 2 equations. Okay. The other way to write this is, and to keep the matrix, is to write it this way: 1 2 4 1 times, you have 3 variables, right, equals 0. Okay. So a system of linear equations where the constant right hand side are all 0 is referred to as the homogeneous system of linear equation. Okay. When you see homogeneous, you know, like, oh, okay, like they are 0. Okay. Okay, so when we have a matrix, we can think of it as a system of linear equation, homogeneous linear equations, because and then what we know, so we can write this in a more compact form. Okay, when you look at these variables, okay, when you think about the solution of these linear systems, it has to be some assignment to these 3 variables. So a solution to this system consists of 3 numbers. Okay, and we can refer to it as, we can think of it as a vector as well. So we have vector x that is an assignment of like 3 variables. Okay, this vector x, and we can think of the set of all possible solutions of this as this set. So we have this set, the set of vector x such that ax equals 0. So this is the set of all possible solutions of this linear system. Okay, and from, you know, somewhere maybe last week or last 2 weeks, we talked about, and we know that this set, okay, is a vector space. Okay, so this is another vector space that you can obtain from A. But what exactly is this space? Okay, what exactly is this space? What are inside this set? So this is a set of vectors. It's not a vector anymore. It's not a vector. It's a set of vectors. You have a bunch of vectors inside it. Okay. And what are the vectors inside this set? Give me one example. So a vector inside this set has to satisfy these 2 equations. Okay. Give me the easiest example. 0. Okay. So we know that this belongs to this set, right? But what else? So this set is not empty. You have something inside it, and in many cases you only have one vector where it is 0. But this system of linear equation has other solution as well. Okay, why is that? You can think of it this way. So if you have, so the last equation, you have these 2 variables, right? So basically you can set anything on x3. You can set x3 to be anything. You can compute x2. Okay, so to satisfy the last equation, you pick anything to be, you can set x3 to be anything, and then you compute x2. And now when you have x2 and x3, you can plug into this equation and you can compute x1. Okay, so there's one variable that you can set. You can set x3 to be anything, and the other variables just, you know, change the value depends on x3. Okay, So it has infinitely many solutions because you can pick x3 to be anything, right? In the real numbers, okay? But I'll show you how to do that in more formal form, okay? And this is what we will do in the exercise as well, okay? So we will write this space as a span of some set of vectors, okay? And we refer to this as this set. This is a null space of A. Okay, it's null space of A. So the null space of A is a set of vectors that is the solution of this, but it also has other meanings. Okay, I'll show you later, but let's look at this in terms of a set of linear equations. Okay, so let's try to compute exactly what in A. Okay, so as I told you, I can set x3 to be anything, and I can get x2, right? So let me do this. Okay, so I have these two equations. So let me try to. Okay. So let's do something here. So let's try to work on it here. Okay. So this is my first equation. This is my second equation. So from the second equation, we have that x2. We have that x2 equals minus 3x3, right? Okay, and we can take this and plug in this into equation 1. Okay, we plug in to equation 1. So we have x1 equals 2x2. So 2x2 becomes minus 6x3 plus 4x3 equals 0. Okay. If you solve it, you see that x1 equals 2x3. Okay, so we know that x2 is this, x1 is this. These two variables depends on x3. Okay, so when we want to say the null space of A, this is a set of all vectors x such that ax equals 0, right? But what does it look like? It looks like this. So it's going to be x1, x2, x3, right? It has 3 variables inside it. But what is x2? So x2 is minus 3x3. What is x1? Is 2x3. So it's this set. So the solutions, the set of all vectors that satisfy these solutions is in this form. If you take whatever you put into x3, you put the first column to be 2x3 and 3x minus 3x3 and then x3. This is the solutions. So this is the set. So the set doesn't look like something crazy. Okay? What does it look like? What does this set look like? So you have one variable, x3, right? And all the coordinates just depends on x3. Okay? So if you set x3 to be 0, it's 0. If you increase x3, what is the vector? What does the vector look like? So you think of this as 3 dimension, a vector in 3 dimension. Okay? If you increase x3, the first coordinates increase twice as fast as the last coordinate, right? So this is like the last coordinate. Maybe you think of it as the value in the z axis. So this moves twice as fast, this moves thrice as fast, but in the other directions. So this, what does this look like? It looks like a line. Okay, so it's a line in the 3-dimensional space. Okay, how can you see that it's a line? Let me write it in the other way. Okay, so these vectors. So let me rewrite it this way. Let me take out x3. x3 is a real number, right? So you have this vector, right? And you scale it by x3. Okay? So this is the vector, and this is the set of all scaling of this vector. So it looks like a line. Okay, do you see now? If you don't see that this is a line, you're in like deep shit. You're in deep trouble. Okay? Okay. So if you cannot imagine this inside your head, and you want to pass this course, you really need to work hard. I mean, extremely hard, because we like more than halfway to the second half of the course. Okay. You can put it in GeoGebra to help you think about the geometry of this. But if you cannot imagine stuff like this in your head, that means you completely like clueless about what we are talking about today. Okay, so let me tell you once again. Okay, so let me draw you a pictures. So in 3 dimensions, like what is this vectors? So maybe this is like x, what is x, y, z, right? So it's like 2 there, minus 3 here. So it's a vector that look like this. And when you scale it, right? So it look like a line, like that. Okay? So this is a vector space. Okay? And this is now space of A. And what is the dimension of this space? What's the dimension of this space? The dimension is the number of linearly independent vectors, right? That span the space. But if it's a line, you can only have one linearly independent vector, right? So the dimension of this is 1. Okay, so the dimension of the null space of A is 1. And what is the dimension of the row space of A? What is the rank of A? 2. Okay, because it's in row echelon form, right? So all the rows are linearly independent. So the rank of A is 2. Okay, and the dimension of the row space is 2. Also, the dimension of column space is 2, because the dimension of column space and row space is the same. Okay. And the dimension of the null space of A is 1. Okay, so let's look at a more complex example. Let's work on this. Let's work on this method B. Be easier, much easier for us. Okay. So just ignore A for a bit. Let's look at B. Okay. So we will try to find the null space of B. Okay, we try to find the null space of B. It will be the same as the null space of A. Let me tell you. But it will be easier, because to find the null space of A, we need to do row operation to get to this as well. Okay, so same thing. So the null space of A, in this case, is going to be the set of vectors such that AX equals 0. Okay, but it's the same vector as the set of vectors that BX is 0, because we just perform row operation to get to this, right? So the solutions are equivalent. Okay, so we look at this. Okay. All right. So what is the null space of B? Okay. So so let me rewrite the equation for a bit. So it's x1 plus 2x2 plus x4 equals 0. 3x2 plus x3 equals 0, and finally 2x4 equals 0. Okay. Now, if you want to solve it, we can see that x4 is 0. You cannot set x4. You cannot do anything with x4. Okay. Yeah, really poor guy. Okay. So x4 is 0. Nothing you can do about it. Now, let's move on to this equation. If you look at this equation, you can see that to satisfy this equation, you can set x2 to be whatever you like. You can derive x3. Or on the other way around, you can pick x3 to be anything you like, and you can find x2, right? So yeah, pick one. Do you want, which one do you like? Do you like x2 or x3? You get to the same thing. Okay. Okay. Just use x3. Okay. So let me highlight it with that you like x3. So we will write everything in terms of x3 as we can. Okay. So with this, we know that x2 is equals minus x3 over 3, right? Okay. Yeah, and then we can, and we know that x4 is 0. Now we have these three variables. We can plug it in the first equation. So we see x1 plus 2x2, right? 2x2, but x2 is this, so it's gonna be plus. Oh, that's hard. You should have picked x2, but I'll be fine with that. Okay, so minus 2x3 by 3, right? And then you don't have x3, right? x4 is 0, so just ignore it. So I get this. So I have that x1 is 2/3 x3. Okay, now I have everyone in terms of x3, right? It might not be the case. It might not always be the case. Maybe sometimes it depends on two variables. But this case, it's okay. It depends on just one variable. So we can write it down as, so our solution x1, x2, x3, x4, you cannot use anything, right? So it has to be in this form, like 2/3 x3 and minus 1/3 x3 and then x3 and 0. Okay, you cannot do anything with x4, right? x4 is 0. Okay, so it's a vector in 4-dimensional space. Okay, but the last guy is 0, so you can think of it as 3-dimensional space with some unknown space. But what does this look like? It looks like a line again. Okay, so the set of the null space of B. Now space of V is this vector. So let me write in the one line form. So it's going to be x3. You can just throw away x3 and put it in alpha. Okay. 2/3 minus 1/3 1 0. Like for alpha in. Okay. So what's the dimension of this space? It's a line, right? What's the dimension of the line? 1. Okay. So the null space of A and null space of B is a line. Okay. And the dimension of that. So let's try to do this with the matrix in the exercise. Oh, before we do that, so let me tell you one more thing. Okay. I will remind you later. Okay. The null space of the matrix. What exactly is the null space of a matrix? Okay. You think of null space of the matrix. So a matrix is just a numbers, but we talk about it today. Okay. In every applications of like linear algebra, like machine learnings and like when you do neural network. Okay, you do always you do matrix multiplications. Okay, but you can see that when you do matrix multiplications, there are sets of vectors that will be invisible after these matrix multiplications. ฟังนิดนึงครับอันนี้สำคัญ Okay, so if you have any vector inside this set, you multiply it with A. What do you get? You get 0. Okay, so when you think about this as like you have a neural network, and the first layer of neural networks, basically you do the matrix multiplications, and you can see that when you do metric multiplication, there are set of vectors that would become 0 after the metric multiplication. So this means like, you know, if you have some inputs, and if part of the input belongs to the null space of the matrix, it will be gone. It will not change anything. Okay, you can like move, like you have a vectors, and you move the vector whatever you like inside this space, you won't change any results. It means like this is something that the neural network or the matrix doesn't see, because it belongs to the null space. That's why we call it a null space, because it's null. It's like nothing. We don't see it with this matrix. Okay. You see some more about this later on. Okay, but that's the point. That's what we talk about when we talk about null space. Okay. All right. So let's get back to work on our exercise. We'll start with this metric B. Okay. So let me copy metric B. Okay. So we'll compute the null space of B. Okay. We compute null space of B. So that's the set of equation of this, the set of solutions of this homogeneous linear equation. Again, what does it mean to be homogeneous? So a system of linear equation is homogeneous when you have 0 on this. เราจะเรียกว่าเป็น homogeneous ถ้าทั้งไอตัวเนี้ยครับเป็น 0. If you have non-homogeneous, it means like it can be non-zero, but homogeneous linear equation has the right-hand side constant 0. Okay. So we look at the solutions of this homogeneous linear system. Okay. So so we look at these equations. So we have, let's call we have x, right? Let's x be this 4 variables. So the first equation is like x1 plus 2x2 equals 0. The second equation is like minus x2 minus 2x2 plus x3 plus x4 equals 0, and then x4 equals 0. So let me move the whole thing. So the null space of matrix B is the set of solution of this system. So what does it look like? First of all, you cannot do anything with x4, right? So x4 is 0, right? Now, in the next equations, how many variables do we have left? So x4 is 0, so it's just gone. Okay? Now in this equation, you have, how many variables do you have? 2. So to satisfy them, you can set one of them. Okay. Now this time, which one do you like? x3 again. It will be hard. Let's pick x2. Okay. It will be easier if we pick x2. Okay. So let me pick x2. You can see that x4 is already 0. So you cannot set it. Okay. The next equation has 3 variables, but one variable is like done, 0. So you have two free variables. So you are free to pick one. So let's pick x2. Okay. So now I can write with this. I can write x3. So x3 is gonna be equals to 2x2 plus minus x4, right? But x4 is 0, so this is like 2x2. Okay. So I have this x3 to be 2x2. Now, the last equation has x1 and x2. x2 has already been set, right? Because we pick it here. So x1 has no choice. So x1 is minus 2x2. Okay. And x2 is x2. Now we have these three variables. These 4 variables left. So the set of all possible solution is what? So the set of solution. The set x given bx equals 0 is this set. What exactly is this set? Can you write it down? So it's some set that depend on x2. And can you write it down in terms of like span? Span of a set of vectors. But what exactly is this vector? Just one vector, I think. Okay, so if you plug in all the variables that we have worked on, so we get that the x4 is 0, x3 is 2x2, x2 is x2, and x1 is minus 2x2, right? And you can see that this is a span of this vector, so this vector is minus 2, 1, 2, 0. It's the same thing as you can change, like, because the span, this is span of this vector, right? But if you scale this vector, you also get the same span. So you can, if you answer minus 1, 1 half, and 1, that's also correct. You can also answer 1, minus 1 half, minus 1, that's also correct. So whatever, you multiply this with anything, it's going to be correct. Unless you multiply with 0, you multiply with 0, everything is gone. Okay? Now, what is the dimension? What is the dimension of the null space of A? It's a span of one vector, right? So the number of linearly independent vector of this space is just 1. So the dimension of the null space is 1. Okay. So let's do one more practice. So suppose you end up, so let's look at another vector C, vector D, matrix D. So matrix D look like this. So this is matrix D. So it's roughly the same matrix, but I add one more column to it. Okay. It's minus 2. Okay. Now the null space of D is this vector X, right? So vector X, now you have 5 elements now, such that dx is 1, 0, and it's a subset of this r to the 5th. Like previously, this null space, this is a subset of r to the 4th, right? You have 4 variables, but now we have 5. Okay. 5 in D, and write it as a span of a set vectors. All right, so let's work on it. Okay. Okay. So let me just ignore the equations. I'll work on it. I won't write it down. If you look at the last row, right, you have x4 plus 2x5 equals 0, right? Now you can see that you have one equation with 2 variables, so you can pick one that you want to set. So which one do you like? So let's pick x5. Nice. So given x5, I can know that x4 equals minus 2x5. Okay, so this is like the first one that we know. Okay, now let's plug it into this one. So this equation is minus x2 plus x minus 2x2 plus x3 plus x4 equals 0. Okay, now x4 is set, but somehow x4 depends on x5, right? x3, now we have 2 variables left, x2 and x3. Which one do you like to set? So let's set x2. Okay, so if I just pick x2, I can solve for x3, right? So x3, oh no, I can solve for x3 equals 2x2 minus x4, but x4 is minus 2x5, right? I want to get rid of x4 because x4 now depends on x5 now, right? So x3 is minus x4, so it's plus 2x5. So this is x3. We don't have to work on x2 because it's the variable that we will set. So finally, we have the last equation, x1 plus 2x2 equals 0. So I change it to x1 equals minus 2x2, right? Okay. So my solution look like this. So this set ND equals, so what are the vectors? So x1 is minus 2, x2, x2 is just x2, okay, x3 is 2x2 plus 2x5, x4 is minus 2x5, x5 itself. So this is my vectors, but it depends on how many variables that it depends on. 2 variables. Okay, so this set is going to be x2, x5 belongs to real numbers. Okay, it's more complicated than the previous example, but that's how it looks. Can you write this in terms of span over vectors? Do you see any? Can you view this as a span over vectors? There are 2 vectors combining each other here to become these vectors. Do you see 2 vectors? So one depends on x5, right? So these are variables that depend on x. These are the parts that depend on x5, and these are the parts that depends on x2, right? So you write this. So let me do it in 2 steps. Okay. So let me try to rewrite the whole thing as this. So let me try to rewrite this as this. So this is basically this set. So you have x2 times minus 2, 1, 2, and then 0, 0 plus x5, 0, 0, 2, minus 2, 1, given x2, x5. Okay, so this is a span of 2 vectors. Well, what are they? What are these vectors? Now, what's the dimension of ND? Now, space of the 2. You should be able to do this. It will be in the final exam. Exactly like this. Not exactly this matrix, but you're given a matrix and then you are asked to find like the rank of the matrix, the null space. Okay. So these 2 vectors, what are they in terms of ND, the null space of D? So this 2 vector, this set of 2 vectors is a basis. ไอ้คู่นี้คือ basis. Okay, it's the basis of the null space because 2 things. One, it span. These 2 vectors span the null space, right? And they are linearly independent. When you have vectors that span the space and also linearly independent, we have a basis.